Hi, welcome back. Today we are still continue with the subtopic of Lewis structure. In this video, we are going to continue with draw Lewis structure, but we are going to focus on Lewis structure with double and triple bond. At the same time, we also going to determine the formal charge for each atom in the Lewis structure, and then lastly we're going to choose which Lewis structure is the most plausible if we're able to draw more than one Lewis structure. Let's start with the first example in this video, carbon dioxide. So now when we draw the carbon dioxide, we try to follow the 4 steps that we learned in previous video. Step 1, calculate the total valence electron. So carbon has 4 valence electrons, oxygen has 6, and we have 2 oxygen here. So total is 16 valence electron. This is step 1. Step 2, we are going to determine the central atom. In this case, carbon is the central atom. And then we draw the skeletal structure for carbon dioxide. So step 4, we are going to distribute electron to each terminal atom until octet. Then now we check is there any extra electron. Since we have 2 terminal atoms, each terminal atom has 8 electrons times 2 equal to 16 valence electron. So initially in step 1 is 16, now also have 16, so means that there is no extra electron. However, then we notice that the central atom is not octet yet. Okay, so we are continue with step 5. What we are going to do so that the central atom achieve octet. Okay, if central atom not octet yet, a pair of electron from the outer or terminal atom, outer atom also can be considered as terminal atom, is moved to form either double or triple bond. So for example, in this case, I'm going to move one pair of valence electron. Let's say we move this pair of valence electron. Okay, so now we will form one bond here. Okay, I move now the carbon haven't achieved octet yet, only have 6 electrons. So let's say now we move another pair electron from another oxygen, and then we form another one bond here. So at this moment, carbon dioxide, not just only oxygen achieve octet, but the carbon central atom also achieve octet. Now let's continue with another example here. Draw the following Lewis structure, oxygen. As usual, step 1, we calculate total number of valence electron. Oxygen have 6 valence electron. We have 2 oxygen here, so equal to 12 valence electron. So one of the oxygen atom will be the central atom and the other one will be terminal atom. So ensure that the terminal atom is octet. Okay, make sure terminal atom is octet. So now this terminal atom have 8 electrons. So we have extra 4 electrons. So this extra 4 electron we are going to place it at central atom. So when we check here, central atom only have 2, 4, 6 electron. So what we're going to do? Yes, very good. Like just now, we are going to move one pair of electron and form a double bond. So at this moment, all the both oxygen consist of 8 electrons, 2, 4, 6, 8. 2, 4, 6, 8. So this is the Lewis structure for oxygen. Repeat the step again. When draw the Lewis structure for nitrogen, nitrogen has 5 valence electron. Here have two nitrogen, so total have 10 valence electron. One of the nitrogen as the terminal atom, so we have to make sure the terminal atom is octet. Minus 8, there extra 2 electron. So in this case, the 2 extra electron will put at the central atom. So then now central atom not achieved yet, we are going to move the lone pair electron from the terminal atom to form double bond. Even after form the double bond, the central atom of nitrogen still haven't achieved octet yet. So again, we are going to move another pair of lone pair electron from the terminal atom to share with the central atom. So at this moment, you will notice that both central atom and also terminal atom of nitrogen consist of 8 electrons, and the number of total valence electrons are 2, 4, 6, 8, and 10. So you will notice when we draw the Lewis structure for oxygen and nitrogen, it is a bit different. The way is different from what you learn in SPM. Continue with the next molecule, which is hydrogen cyanide, HCN. As usual, step 1, calculate the total valence electron. Hydrogen 1, carbon 4, nitrogen 5. Total is 10 valence electron. In this case, carbon will be the central atom. Even hydrogen is the first element in the formula, but do keep in mind hydrogen never be central atom. Okay. So carbon is central atom bonded to terminal atom nitrogen and also hydrogen. Now we are going to assign electron to the terminal atom. We are not going to assign any electron to hydrogen because hydrogen always duplet. One bond has 2 electrons, so already duplet. Then now we are going to octet the nitrogen. 2, 4, 6. Okay, so now let's check, is there any extra electron? So 2, 4, 6, 8, 10. There is no extra electron. But then at the same time, we notice that the central atom of carbon haven't achieved octet yet. So we are going to move one pair of electron from the terminal atom to form double bond. However, at this moment, carbon still haven't achieved octet yet. Means that we are going to move another pair electron. So at this moment, carbon is achieved octet, nitrogen octet, and hydrogen duplet. So this is the Lewis structure for hydrogen cyanide. Example number 5, nitrate ion. First step, calculate the total valence electron. Nitrogen 5, oxygen 6 times 3, total is 18. Negative 1 means that we are going to gain 1 electron. So total up the number of electron is 24 valence electron. In this case, nitrogen is the central atom. So bonded to 3 different oxygen. Now we are going to make sure each oxygen is achieved octet. Okay, since there are 3 terminal atom and then each terminal atom have 8 electron, 3 times 8 equal to 24. So minus 24 here, we have no extra electron. Okay, then again, when we look at this central atom, the nitrogen only consists of 6 electrons. So that's why we are going to move one pair of electron from the oxygen to form double bond. So at this moment, nitrogen already achieved 8 valence electron. Same with another 3 oxygen. So this is the Lewis structure for the NO3 negative. So reminder again, don't forget the sign negative over here. Last example before we proceed to another step number 6. Okay, this time we are going to draw carbonate ion, carbon 4 valence electron, oxygen 6 times 3 equal to 18. And then we're going to charge -2 means that we're going to get 2 electrons. Total up is 24 valence electron. This time carbon is the central atom. So going to bonded to 3 different oxygen. Each oxygen need to be octet as usual. Don't forget the charge. Okay. This carbonate ion, similar with the example of nitrate ion just now, the central atom of carbon, in this case, also haven't achieved octet yet. So we are going to move one pair of lone pair electron from any oxygen to form a double bond. Once formed the double bond, so the carbon is already achieved octet. So this can be the Lewis structure of the carbonate ion. Okay, now we still use the example carbon dioxide, which we draw earlier. Try to draw another Lewis structure for carbon dioxide. Recall back just now when we draw the carbon dioxide, we use a double bond in between oxygen with the carbon, and then each oxygen still have 2 lone pair electrons. This is the Lewis structure that we draw earlier. So maybe at that time, some of you will think that, is it possible if I move 2 lone pair electrons from the similar oxygen? Yes, it is very good if you have this idea, means that carbon bonded to oxygen. So oxygen try to achieve octet. There is no extra electron. So we have to move the lone pair electron. Let's say we move 1 lone pair to form double bond. After form double bond, the carbon haven't achieved yet. So we know we need to move another lone pair. But this time we move the lone pair from the same oxygen to form triple bond. At this moment, carbon also achieve octet 2, 4, 6, and 8. Okay, so if there is 2 structure, how we going to know which one is correct or either one can be accepted? So that is why we need to continue with step 6. Now let's continue with step number 6. Calculate the formal charge for each atom in the structure. So how to calculate the formal charge? Okay, so let's look at the formula here. Formal charge is number of valence electron in free atom, and then we minus the number of electron assigned to the atom. These are the Lewis structure that we drew earlier. So now let's calculate the formal charge for the atom. Do remember when we calculate the formal charge, we are going to calculate the formal charge for each atom in the molecule. Each atom in the molecule. Okay. So if you still remember just now, the formula is number of valence electron in free atom. So oxygen has 6 valence electron minus how many electron assigned to it. Okay, so when we do like this, is here. Okay, we do a circle like this and then we calculate 1, 2, 3, 4, 5, 6. So going to -6 equal to 0. So now we go for the carbon. 4 valence electron minus 1, 2, 3, 4. so equal to 0 as well. So now the next oxygen, 6 valence electron minus 1, 2, 3, 4, 5, 6. Minus 6 equal to 0. So means that the formal charge for each atom are 0. Now let's look at the oxygen with the triple bond. 6 valence electron minus 1, 2, 3, 4, 5 equal to positive 1. This one 4 valence electron minus 1, 2, 3, 4 equal to 0. While for the oxygen with single bond is 6 minus 1, 2, 3, 4, 5, 6, and 7. So 6 minus 7 equal to negative 1. Okay, so after we calculate the formal charge for each electron, we need to decide which one is the most plausible Lewis structure. Okay, after calculate the formal charge for both molecule or both Lewis structure that we draw, so now we need to check which one is the most plausible. So what is the meaning of plausible in this case? We consider the most stable, the most structure, the most best structure is considered as plausible. Okay, so plausible, stable, plausible, stable, best are considered the same meaning. So all these supposedly will be the one with the lowest formal charge, where means it is nearest to 0. So based on just now, carbon double bond with the oxygen, the formal charge is 0, 0, 0, while triple bond and single bond, this one is positive 1, 0, negative 1. So in between these two, the first structure with both double bond is the most plausible structure. Okay, how about if the compound or consists of negative ion, negative charge? If there is negative charge, your total formal charge must be always in negative as well. And then the negative charge will go to the atom with the more electronegative. Same case happen if the molecule are with the positive charge, you also will get the total formal charge is positive. So then this positive charge have to go to the one with the more electropositive atom. Before we continue with to determine the most plausible structure with positive and negative charge, let's look at one more example, which consists of Lewis structure, which is the most stable. Okay, so when we look at here, this is BCl₃. Okay, as we look at here, BCl₃ have no charge. So if there is no charge for this compound, most probably we want to get all the atoms consist of the formal charge which are equal to 0. Okay, so let's check the formal charge here. Chlorine have 7 valence electron. So here have 1, 2, 3, 4, 5, 6, 7. Minus 7 equal to 0. I will repeat for chlorine, another 2 chlorine, because the condition is similar with the first one. Okay, so I also know this formal charge for this all the chlorine in this compound is equal to 0. Then now we focus on the boron. So boron have 3 valence electron, and then here have 1, 2, 3. So minus 3 equal to 0. Okay, even though the boron is not achieved octet yet, but in the previous structure we did learn about exceptional octet. So boron is one of the example that will show incomplete octet. Okay, If you still want to make it in the double bond, it's okay, no problem. Then let's calculate the formal charge. Okay, so this chlorine no need to repeat because similar with previous structure, which with the single bond. So now this boron have double bond. So we are going to use 3 minus 1, 2, 3, 4. So will equal to -1. While the chlorine with the double bond, we will going to 7 minus 1, 2, 3, 4, 5, 6, which is equal to +1. So compared to the structure 1 shows lowest formal charge because all the formal charge are 0. Okay, while for the second is not the plausible because the positive charge is on the more electronegative atom chlorine. Between boron and chlorine is at the right hand side. So generally we know across the period electronegativity increase, but the positive charge is fall on the more electronegative element, so it is not logic. So we are not going to choose structure 2 as the plausible structure, but will be choose structure 1. Okay, this is just a very quick summary. Do remember, for the neutral molecule, the sum of the formal charge always will equal to 0. While for the ion, the sum of the formal charge always will equal to the charge of the ion. Okay, we will continue with next example in tutorial 7 later, but generally just would like to let you know. For example, if you have just now we draw NO3 negative, means that the total formal charge for the nitrogen and these 3 oxygen total up will be equal to -1. Okay, this is the meaning. When an molecule, for an ion molecule, the sum of the formal charge always equal to the charge of the ion. If you have CO₃ 2 negative, the formal charge always will be equal to -2. Okay, let's look at how we're going to determine the most plausible structure. According to this question, we are going to draw the structure for OCN negative. So as usual, step number 1, we're going to calculate the total number of valence electron. Oxygen 6, carbon 4, nitrogen 5, negative means gain 1 electron. So total 16 valence electron. Step number 2, then identify central atom. In this case, even oxygen is in the first element in the formula, but it is not central atom. Okay, because oxygen is the most electronegative among these 3. Okay, among these 3. As we already know, central atom always is the least electronegative element. So in this case is carbon, central atom. So step number 3, we are going to draw the skeletal structure. So O connected to carbon and then carbon connected to nitrogen. Step number 4, we are going to assign electron to the terminal atom until octet, which here is oxygen and nitrogen. So and then, because of there is 2 terminal atom, each terminal atom octet, so 8 times 2, 16 minus 16, there is no extra electron. So then next we are going to proceed with step number 5. Is the central atom octet? So obviously it is not octet. So we can form the multiple bond in between carbon and oxygen or of carbon with nitrogen to make sure carbon is octet. So in this case, we have 3 possibilities, okay, which I will show you in the next slide. Okay, these are the 3 possible structures that we're able to draw. Structure A, where carbon-oxygen single bond. Structure B, carbon-oxygen triple bond. In structure C, carbon-oxygen double bond. So because we have more than one Lewis structure, then we have to calculate formal charge. Step number 6, calculate formal charge to determine the most plausible Lewis structure. So look at structure A first. For the carbon, 4 minus 4. For oxygen, 6 minus 7. Nitrogen, 5 minus 5. So when you look at here, we will notice that the total charge here, -1 plus 0 plus 0 is equal to -1. So in this case, we are no need to show the bracket and then put the negative sign is okay. Because based on the formal charge, we total up here -1, 0 and 0 also equal to -1. So we no need to repeat same thing for 2 times. So this case, we no need to show the negative charge, the overall negative charge. Okay, proceed with the calculation of formal charge in structure B. In this case, carbon still have formal charge 0, but oxygen +1, nitrogen -2. When we total up, we still will get 0 plus +1 minus 2, -2. We get the total charge is -1. Proceed to structure C. Carbon 0, oxygen 0, formal charge of nitrogen -1. So total again is -1. So when we look at here, all these 3 Lewis structure has the total formal charge equal to -1. Which one is the most plausible? So as we already know, most plausible means that they're going to have lowest formal charge. Okay, the most easiest for us to understand, if the lowest formal charge, that means the formal charge always equal to 0. So in this case, among A, B, and C, I think we will out the structure B first, because structure B only have a formal charge with 0, while structure A and C have 2 atoms with the formal charge of 0. Okay, after we eliminate one possibility, there are still 2. So then we continue with another concept that we learned in the previous slide. Atom which is more electronegative, suppose will have the negative charge. Okay, so when we look at structure A, those who with the negative charge is the oxygen. While in structure C, the negative one of formal charge belongs to nitrogen. Between oxygen and nitrogen, oxygen is more electronegative. So to keep in mind that the most electronegative element in the periodic table is fluorine, followed by oxygen, and then the third one is nitrogen. Therefore, in this case, oxygen is more electronegative, and its formal charge supposedly have to show -1. So that's why in this case, structure C also will be out, and the structure A is the most plausible Lewis structure. Okay, let's continue with tutorial question 7. Based on the skeletal structure of peroxynitrate OONO negative, draw all possible Lewis structure, calculate formal charge for each atom, and then identify the most stable and explain your answer. So before we start this question, just would like to let you know, this question already identified the skeletal structure for us, which means that the arrangement of the of the atom is arranged like this. Oxygen connected to oxygen, and then connected to nitrogen, and then connected of oxygen. So means in this case, we no need to identify the central atoms. Okay, as usual, start with step number 1, total valence electron. There are 3 oxygen here. Each oxygen have 6 electrons. And then we gain nitrogen have 5 valence electron, gain 1 electron. So total here we have 24 valence electron. Step number 2 can skip. Step number 3 is given here. Then now step number 4, we are going to assign electron. So this time when the way we assign electron also a bit different from the previous one, because previously we only have one central atom and then the others are terminal atom. But in this case, we have no idea which one is the central atom, or we can say they might have more than one central atom. So that's why we starting from the left and try to ensure every element achieve octet. So this oxygen need another 2 lone pair, same case with the nitrogen, and then oxygen need 3 lone pair. Okay, but please remember that you have to calculate the number of valence electron. Is it enough or not enough? Okay, so we start from here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So based on now here we have 26 electrons. But here we only have 24. Means that you already draw extra 2 electrons. So that's why we erase 2 electrons first. And then now the electron is 24 electrons. Okay, then next we are going to check. We will notice that the last oxygen only have 6 electrons instead of 8 electrons. So what we are going to do, if the atom is not achieved octet yet, so we are going to form double bond. So one of the lone pair from the nitrogen will be going to form double bond with oxygen, so that both nitrogen and oxygen can be in octet. Okay, so after we draw this structure, then we can calculate the formal charge. First oxygen at the left hand side here, 6 minus 7, we get -1. Second oxygen here, 6 minus 6 equal to 0. While nitrogen, 5 minus 5 equal to 0. Last one, oxygen, 6 minus 6 equal to 0. Okay, after we draw the first Lewis structure here, again, I think you will have the idea. Basically, we can form another way round. Okay, maybe we try to look at another structure. Still O, O, and O. How about if this time we assign the electron from the right side? 1, 2, 4, 6, and then here needs another 2 lone pair. This one also need another 2 lone pair. And then here, since the electron already have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So means that still have another 4 electrons. So have 2 lone pair here. So again, you will notice that the oxygen at the most left side at this case has not achieved octet yet. So if haven't achieved octet yet, again, we are going to move 1 pair of electron next to it, and then going to form 1 double bond. So at this case, all the atom is already achieved octet. So again, we are going to calculate the formal charge. So in this case, the oxygen at the most left side, 6 minus 6 equal to 0. Oxygen at second oxygen also 6 minus 1, 2, 3, 4, 5, positive 1. 5 minus 6, negative 1. And then 6 minus 7, negative 1. So you will notice the total formal charge here is equal to -1 as well. So this question actually, we still have one more Lewis structure at where this time the double bond might in between O and oxygen and nitrogen. Okay, so we can draw 2, 4, 6. So this one still need another 1 pair electron. This one need 1 lone pair, and then this one still have 3 lone pair electron. So again, we calculate the total valence electron: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 24 electron. So like usual, we are going to determine the formal charge. For this case, oxygen is single bond, so it's 6 minus 7 equal to -1. And then second oxygen have 3 bonds, so it's 6 minus 1, 2, 3, 4, 5, +1. Nitrogen 5 minus 5, 0. And then single bond oxygen is -1. Again, you will notice at this case, total formal charge also equal to -1. So we have structure A, structure B, and structure C. Okay, so we already done for first part, all the possible Lewis structure. We also already calculate the formal charge. Then now we are going to choose for the most plausible structure. So in this case, A is the most plausible. So explain your answer. Generally, the answer will always say that A is the most plausible or most stable Lewis structure because A has lowest formal charge. Okay, so that's all for this question 7.